This is your first set of notes for 6A. We are talking about transversals. It is really about angles here. So here are the 2 pages that you will need to cut from your pathway packet and glue into your journal for today's notes. However, I'm going to start with a paper that you don't have, and I'm going to talk to you about what angles look like and what they do. So first of all, here are some different angles that you might see on this paper. You might remember that angles are called acute and obtuse. The acute angles are the ones that are little bitty tiny cute angles. They are here, right? And then you have obtuse angles, which look like these angles here. If we actually wanted to measure how big these angles were, we would take this thing called a protractor and line it up in the middle. So this dot goes in the middle of the angle here, and I have to read the numbers the right way. I can't read these big numbers because it's going smaller, or biggest to smallest. So I'm going to read these numbers. So it goes all the way to about 40 something or 30 something, right in between 35 and 40. So I'm going to say that this angle is about 47 degrees. And then I'm going to use a little arrow notation to say that that is an angle. So I would write this as angle ABC equals 47 degrees. And then I could do this for the angle over here too. I'm telling you this so that you know how to read angles whenever you're asked to read angles. You might not be able to see the numbers, and that's okay. I'm going to zoom in just in case you can. But if we're looking for this angle here, I kind of have my protractor, and I'm going to need to read using the small numbers again all the way over here, and it looks like it's about 120 degrees. That is a larger angle. So we consider this one obtuse. Obtuse is because it is larger than 90. So this angle DEF is 120 degrees. And then let's talk about what I just mentioned. Right in the middle of acute and obtuse is an angle that looks like this. It goes straight up. You might know what it's called. It makes a perfect corner. And I don't know if you can tell what's in between 80 and 100. It is 90. This is a 90-degree angle. It is indicated by a little box in the corner like this. Remember that it is called a right angle. Anytime you see this corner, it tells you that this is a right angle. So I already know that this is a right angle no matter how I drew it. If your right angle is ever split up into 2 pieces, like here's an angle and here's another angle that's probably maybe different sides, but they add up to be 90 degrees, they are called complementary. Not too sure if I spelled that right, but it doesn't really matter. We're not in spelling class. The next one is a straight line like this one. This one is important because we're going to use a lot of this straight line stuff here in just a second. This one, anytime you have different angles that make up a straight line like this, and I use multiple little angle notations to show that they're all different sizes. These will all add up to 180 degrees because a line adds up to 180 degrees. It is called supplementary. And I'm just going to pretend that I spelled the whole word. And yeah, let's move on to this one down here. These are 2 lines that intersect each other. So remember, lines are 180 degrees. Good to remember. So if I had this angle and this angle, these 2 will have to add up to 180 degrees. So I'm going to pick some numbers. How about 170 and 10? Those add up to 180 degrees. So these 2 angles are supplementary. And here's one other fun fact about anytime lines cross like this. The angle opposite on the opposite side is the same exact size as the one above it. Even this one over here to the side, it is the same exact size as its opposite little pair. These are called vertical angles. Vertical angles. Here's another example. If you ever have 2 lines that are parallel to each other, you can definitely tell they're parallel by little indications like this. They kind of make like double-headed arrows. Those means that the lines are parallel and they will never touch. If you ever have parallel lines, they don't cross each other, so obviously they don't make corners. If you have a line that intersects them, this is called a transversal, which is where our title of our notes and our pathway part come from, pathway 6A-1. And here's a little bit more information about transversal. So here we have a set of parallel lines I can tell they're parallel by the two arrows that indicate they're parallel. And then they are crossed or intersected by a transversal line. And then I have a little example, or a kind of like a clone of a set of the lines that kind of form the angles. So we're going to kind of show how the angles are similar. And I know I'm super short, but I needed to show you so that we can use a see-through, or I needed to have a see-through page, and the glass works great. So let's talk about angles and which ones might be congruent. So I'm going to use a green marker to try to figure out, to show you which one of these is congruent. And I'm just going to kind of shade over. So both of these are green. If I ever slide this set of angles down here to meet the same exact set of angles, I notice that these angles that overlap are the same. So I have two angles that are the same size. So let's just say that this one is 100 degrees, an angle of 100 degrees. That must mean that this angle is also 100 degrees. So I could just know that this angle here is also 100 degrees. I can color it in. I could use just a simple angle notation where it's got like kind of like the little curve in it. So I'm going to use this to kind of see what all angles are this exact size. If I ever took this little piece of paper and rotated it, I would notice that the lines line up again. We have the same angle here, and it is the exact same size. So I'm going to go ahead and put a 100 degrees here for this angle. And then one more down here, which is 100 degrees. All transversals will work the same way. I'm going to go ahead and use a different color and show you that the very last angle will be the same as all the remaining angles. Now, if you don't believe me, I'm about to show you here. So I'll go ahead and just mark this one here. Just have to do one. That's all that really is needed. And our pinks and greens line up. When I rotate it, our pinks and greens line up. Our pinks and greens line up. And again, our pinks and greens line up. However, we don't know what the size of the pink angle is. So here's how we can tell. I know that the whole line, the very flat straight line, doesn't matter which one I use. I can use any of them. A line creates 180 degrees. So if one of the angles along the line is 100, the next one should be 80, because 100 and 80 make 180, which makes sense because these two angles, 100 plus 80, 180. Same thing for these two, 100 plus 80 is 180. And it just keeps going like that. Now that we know how transversals work, let's talk about some important vocabulary that go along with the different types of angles. So first of all, we have supplementary angles. We learned about this at the first of the video. Remember, this is the paper that you have, so this is the one that you should be working on. We are going to say that transversal angles add up to 100, supplementary angles add to 180. So you could pick any of these angles anywhere to add up to 180. For instance, you could pick this angle here plus this angle here. They will add up to 180. Remember the opposite. However, you can't choose a large angle, an obtuse angle, and another obtuse angle. They won't add up to 180. I know, because they won't fit perfectly along a straight flat line like those two angles did. When you are able to fit on a line, you are 180. So now let's go look for corresponding angles. We worked with corresponding sides last unit. Those were sides that were on the same side of stuff. Corresponding angles kind of work the same way. In the last video, you might remember, or in the last part of the video, you might remember how I took a paper and I moved it kind of down and up like that. And I showed you that this angle here and this angle here were the same size, which means these are corresponding angles. They're in the same position and the same size. Here's another example of a corresponding angle right here. They're in the same position and in the same side, or they're also the same size. And if you really wanted to do another pair of corresponding angles, here's another one right here. You can always use highlighters if you want, different colored crayons if you want, but if you don't have those, it is okay. All right, alternate interior angles. Alternate is a good word to understand, or is an important word to understand, so is interior. First of all, we have the words interior and exterior. Interior means inside. Exterior means outside. What we're talking about inside and outside, we're talking about inside and outside of the parallel lines. So either you're on the inside of the parallel lines or you're on the outside of the parallel lines. Alternate interior angles are going to be the same size, which means they're congruent. And they are examples like this. This angle and this angle are the same size. They are on the interior and they are on alternate sides of this transversal. This one is on this side of the transversal. This one's on the other side of the transversal. However, they're still on the inside of the parallel lines and they're the same size. All right, last one is the alternate exterior angles. Works the same way as these. Oh, by the way, here's another set of alternate interior angles. So alternate exterior angles will work the same way. That one and that one are alternate because they're on the opposite sides of the transversal. And they're exterior angles, okay? But they are the same size. Here's another example of alternate alternate exterior angles. All right, and for the final piece of your notes, you have example problems where you are actually going to find, I hope you can see that. Anyways, if y'all didn't, you could pause the video at that point. So here are a couple examples. So first of all, I'm going to locate my parallel lines. There they are. They're right here. Okay. These parallel lines, I can tell they're parallel because of the way they look, but also because of the indications, are cut by transversals. There's a transversal here, a transversal here, and a transversal here. There's 3 of them. On your papers, you will only have a few one set of transversals on each parallel lines, but I gave you a hard one just to kind of see. We're going to fill in the degrees for each of these angles. This is what I mean. If this angle is 115 degrees, that must mean that the vertical angle underneath it is 115 degrees. Or I could have said its corresponding angle, because it's in the same position, is also 115 degrees. I know that. And I could have said the alternate exterior angle is the same size. If you can start seeing these visually with your mind, saying that that's the same size as that, and that, and that, and they're all the same, you can definitely just go off of it that way instead of thinking of all those crazy names. However, I know the names, so I'm going to say them. The next thing I need to do is figure out what the other angles are. And if I know that this line here is supposed to add up to 180, part of it is 115. So if I take 115, take 180, subtract 115, I get the remaining angle size, which is 65. So I can go put 65 on all of these missing angle sizes as the correct degree amounts. If you want to use different colors again, you definitely can. All right, now down here we have an angle with 2 little lines saying that it's 43 degrees. If I know that this angle over here is going to be the same size because it's an alternate interior angle, I can go ahead and put 43 degrees on it, just like that. I also know that this angle above the 43 that I just made is a vertical angle, so it makes the same size. And then down here, these 2 angles are corresponding. They're in the same position. So they are 43 degrees, both of them. Now, in order to figure out the next 2, I can tell that this straight line should have had these 2 angles to equal up to 180. So if I take 180 and subtract 43 from it, I get 137. So my other angle, and I'm only going to do one little curve thing for it to indicate that this is a different size. It is a 137 degree angle, and I get to fill in everything else with the same number. And then last but not least, the transversal down here. Now I see no numbers, I just see one box, which tells me that this was a 90-degree angle. The nice thing about this is I know that that is also 90 degrees because it is a vertical angle. But here we go, let's figure this out real quick. If this is supposed to add up to 180 because they're along the same line, they create 180 degrees, 90 plus 90 is 180. I know that because 180 minus 90 is 90. So that means if this angle is 90, then this angle is 90, then this angle is 90, then this angle is 90, 90, and 90. All of this makes perfect little right angles. All of it. And that is how you work with transversals.